Well, good morning. My name is Jesse Lorenz, and I'm a technical evangelist with Salesforce.com. And I'm really excited to be here today to talk about writing unit tests. And I'm really excited that you're all here. I know it's the last session. I don't know about you, but it's been a great conference for me. And I'm finishing off on a high note here because I love talking about unit tests. And see, I know it's weird, right? It's totally weird. Like, who likes writing unit tests? So let me actually get a quick show of hands. How many people here have written unit tests before? Oh, that's actually a lot more than I expected. And let me level set with you. This is a beginning developer session. So we're not really going to get into the detailed stuff. We're not going to talk about governor limits. We're not even going to talk about triggers. This is pretty basic how to write good unit tests at a sort of an abstract level. But I really want you to stay if you're interested. And ask me questions or learn more if you have. A question already. So the question is, will I like unit tests after this? And the answer is, I hope so. I hope so. So of course, before we get started though, safe harbor statement. You know it, you love it. It's on the website. I encourage you to check it out. But actually, there's an even better website for you to go to. You'll notice it at the bottom. But what we're going to talk about today is a couple of things. We're going to talk about what unit tests are. It seems like some of you have a pretty good idea, so hopefully we won't spend too much time on that. And we're also going to talk about why unit tests are beneficial, why they can help you, why they're going to save you time developing. And then we're going to spend the majority of our session today talking about how to write good unit tests. And at the bottom here, there is a session webpage that goes along with this. So if you can't see it, it's bit.ly/goodunittests. And the capitalization of the G, the U, and the T is important, as is that final S. And if you want to, you can go there right now. This URL is live. You can, actually, I think you might not have wireless, but if you get wireless, you can go there. You can take a look at all the content that goes along with this session. There's wiki articles, tons of documentation, and also the source code from today's session. You can download all of that into your org. So I spent a lot of time thinking about this session. I'm pretty excited about this session. And I spent a lot of time searching the internet for a good definition of what unit tests are and a definition that I liked. And this isn't it. I didn't find one. But this guy is, he's pretty famous. He's a pretty important guy. He created the first wiki. And his definition is not bad. But I was talking to a colleague of mine, and he actually has a much better definition. It's maybe a little simplistic. We could argue about it, but I think it's pretty good. Unit tests are programs that verify another program is working, right? That's what a unit test is. So I like this definition. Maybe it works for you. Hopefully it explains what unit tests are if you're new to unit tests. And if not, let's demo it and show you a unit test right now. So I'm a visual guy. So, unit tests are all Apex code. It's a lot of text. So I wanted to have a visual example here of what a unit test is. And so let me show you this example. So this is a Visualforce page. It's pretty simple. And you're going to love the code that's behind this. It's one line long. It's really, really simple. And all this page does is I put in a value here in the denominator of this fraction, in this case 2. And it spits back, the decimal equivalent. So, 1 divided by 2, we know that equals 1/2. We can do this. We can also say, 1 divided by 4, and that equals 0.25. That's a quarter. Right? We know all of that. And so I've got this one line of code behind this page. And, I could sit here all day and I could test this, right? I could put in lots of really interesting numbers like -4 and, maybe some other stuff. And that'd be great. I'd be testing my code, and I'd probably feel really confident that my code worked. But it's not automated, and that seems like kind of a boring job to me. And that's the beauty of unit tests. So let me show you the code behind this page. I'm only going to show you a little bit of it, because everything else is cruft that gets in the way. So here's the code that actually does that division that I showed you before. And it's just this method here. It takes one parameter, the denominator value, and it returns, 1 divided by the denominator. So this is really simple. This isn't the controller. This is just the code that does the division. and I've written a unit test for it. And here it is. So there's a couple of things that I want to point out here. This is a class, right? So that division code that I have is in a class called fraction utility. And I've got this class here called fraction utility test. And I think it's a good idea to put your unit tests in separate classes. But there's one really interesting thing about this class up here, and that's this isTest annotation. That's what the @ means. It's an annotation. And basically what that's saying is that all of the code in this class is just for the express purpose of writing unit tests. That's what it means. There's some benefits to it. It means that this code doesn't count against your Apex code limits. So some of you might have experienced that. You've written 1 meg of code. If you add this to your unit test classes, then this doesn't count against that. And then there's another really important word here, and that's or keyword, and that's in our method definition. And that's this test method keyword. And what this does is this flags this method as a test method, as a unit test. And that's really important because when we run our unit tests, the Force.com platform has to know, which tests are unit tests. And this is the way we tell it that information. And you can see that, there's a pattern to these unit tests, and you'll see that as I go through this today. First step is setting up the conditions to test, and then actually executing the method that you want to test. And then I'm going to talk about this a lot. The most important part, or the most common part that I've seen a lot of developers forget is verifying that the results are correct. Maybe not most important, but certainly most commonly forgotten. And then finally, also a really important part, running the test. So let's do that. There's a bunch of different ways that you can run tests. So I can right-click on my actual class here, and I can go into that menu and select Force.com, and then finally run tests. And so that's going to run all the tests inside of this class. And you can see that I've got my code coverage results here. And we're going to talk about this a little bit later on. There's this number here, 100%. And 100% is kind of relative, it turns out. In this case, 100% doesn't mean perfect. We'll talk about that later. OK, so hopefully we're kind of all on the same page about what a unit test is, what they look like. Let's talk about why unit tests are important. And this is a great question. And the way that I answer this question is confidence. So unit tests give you the confidence as a developer that your code is running the way you expect it to run. This is supremely important, right? If you don't have confidence that your code actually works the way you expect it to work, why are you writing more code on top of that? That's like building your house on top of quicksand, right? Like that's a little iffy. And I am an evangelist. I'm a technical evangelist. But I'm not preaching this to you at all because Salesforce.com, our R&D team, believes in unit tests like you wouldn't believe. We've got a tremendous, huge suite of unit tests. And we are running those constantly and making sure that our development team, that they haven't broken anything. And I've spoken with the product managers over in R&D numerous times, and they credit unit tests with Salesforce.com being able to release 3 to 4 releases every year. Without unit tests, we couldn't achieve that kind of velocity because we wouldn't have enough confidence in our code. So we have tons and tons of unit tests. We run those unit tests all the time. And we've seen the benefits. We think it's incredibly important, especially because your code is running against production data, right? And you want to make sure that your code's not going to mess up that data. So it's really important, really, really important to have unit tests. It's a core part of our software development. It's not something we do at the end. Many times, we actually write our unit tests before we start development. So it's absolutely a critical component. So that's, I think, the really, really important reason for writing unit tests. It's also maybe a little theoretical. You might argue with me about this. So there's another reason why we have to talk about unit tests. And that's that when you write an application, when you write code inside of Force.com, you actually have to have a certain level of unit test code coverage. And this is an example of that. So this is some code we're going to look at later on today. And you can see that there's code coverage here. Everything that's marked in blue has been executed by a unit test. And that one line in red there, that's something that has not been executed by a unit test. And, you know, I talked to a lot of developers. And a lot of developers say, 75%, man, it's really hard. But it shouldn't be. 75% should be a low watermark for you as a developer. And I'm sure some of you want to argue with me about that. I'm certain of it. But think of it this way. That code in red right there, I haven't executed it. I haven't tested it. So how do I know that there's not a bug in there? In fact, I've got no way of knowing that there isn't a bug lurking in that red line right there. So it's really important to test it. I mean, unit tests are not a guarantee that you're going to find all your bugs, right? I mean, Salesforce has found a few bugs themselves. And it's important that when you do find those bugs, though, that you get coverage for that code that has it. So we're talking about unit tests because they're really important. They're super beneficial to you as developers. And Salesforce has recognized that. And there are requirements. So you need to have at least 75% code coverage for anything that's going into production or that you've uploaded to the App Exchange. OK, so we've talked about what unit tests are. We've talked about why unit tests. Why do we need to write them? And so let's start talking about how to write good unit tests. So let's talk about unit test structure. So I alluded to this in that example that I showed you before of that unit test. And traditionally, when you write a unit test, if you come from a Java or a .NET background, there's 4 steps to writing a unit test. You know, the first is you've got to set up the conditions for unit test. You know, you're writing a method, and I'm guessing it's executing against data. So you're going to need data there for that method to execute against. So you've got to set up the conditions for testing. And then you have to actually execute that method or trigger, you know, whatever you're writing. But you've got to execute it. You've got to make sure it's kicking off. And then this is that part that so many developers that I talk to neglect to do. And if you don't verify the results, if you don't use those system.assert calls, then you're really not writing unit tests. And this is one thing you can't argue with me about. If you don't verify that the results are correct, using system.assert, system.assert equals, all of those really important methods, then you're not writing unit tests. You're writing smoke tests, and that's fine, but it's really not good enough. You're just making sure that you're not throwing exceptions. And then finally, typically there's this fourth part where you've got to clean up all that data that you created in the first step, right? Maybe you inserted a record in your database, but you got to back that out so you can run your unit tests again. Well, the great thing about writing code on Force.com is that you don't have to do that. So at the end of every test method that executes, nothing is committed. So that's kind of an important thing that might be new to you if you're coming from .NET or Java, but you don't have to do any cleanup. OK, so unit test structure. So here's that first test method that I wrote. And we didn't spend a lot of time on this. But you'll notice that I'm testing a functional requirement here. So I need to make sure that my unit tests work with positive numbers. And so I've written a positive unit test. But there are negative fractions too. So I need to make sure that my code also works with negative fractions. So I'm going to write a unit test here, another one. And maybe this is important too. Maybe I should point this out. You'll notice that I've got 100% code coverage, but I'm not stopping. I'm going right on. I'm continuing right through. 100%, it doesn't mean anything to me. I'm going to write another unit test because I want to have real confidence in my code. So let me show you what I'm going to write here. So I'm going to write the first step of this test method, this unit test. And that first step is setting up the conditions. And this is the negative test case. So the value that I'm testing right here is -2. And I'm expecting a result of -0.5. So I've set up the conditions for testing. And this is my drum beat here. So this is the second step. And you can see it repeated right up above. Second step is call the method being tested. And so I do that. Here's the fraction utility class, and I'm going to call that getFractionalValue method. And then I'm going to return a result. And then that really critical part of the unit test, verifying that the results are correct. So I'm calling system.assertEquals, and you can see that I'm passing two parameters here. Let me zoom in. So there's an expected result, right? And that expected result is up here, and it's negative 0.5. And then I've got an actual result over here, and that's what was returned by my call to the method I'm testing. And then I'm asserting, I'm checking, I'm verifying that these two values are equal. And so when I run this as part of my testing process, this is actually going to verify that what I expected to have returned actually is returned. And if it's not, this test is going to fail. So, failure? All right. So let's actually change this. That's a really great question. Thanks for asking. So what does failure mean? So what if I expected that the value was going to be negative 0.6? So I would save that. And I'll show you what it looks like to rerun this test. So clear the results. And I'm going to rerun here. And now I get this failure, this warning message that says, hey, you've got this thing that failed. And here's a message, right? Let me zoom in. It's kind of hard to see. So your assertion failed. You expected negative 0.6, but the actual result was negative 0.5. Now, in this case, there's actually a problem. There's actually a bug in our unit test. That's possible. I mean, that happens. It's code. No one writes perfect code. I don't. I haven't met anyone that does. But that's a failure. So let's fix that. And let's save it. And let me actually show you a different place that you can run your unit test to, because there's some extra features there. So I'm going to open up a new tab in Setup. And I'm going to go under Develop here, and I'm going to check out my Apex classes. And I've got my fraction utility test method. And I can run the test from inside of the browser environment as well. And we fixed that problem, so all of our tests should pass. And they do. So we ran 2 tests, but we've got 0 failures. And we've got, again, we're continuing with that 100% code coverage. So we've executed all of those lines of code. And there's one really neat thing here, and boy, it's kind of hard to find if you don't know exactly where to look. So there's my John Madden impression right there. So this is code coverage, and it's showing that we're covering 100% of the code. And when we actually click on this link, something really neat happens. Don't click on this one. This is like the trick link. You're going to click on that, and you're just going to see the class again. But click on this one, and code coverage is 100%. And so here's that picture again of code coverage. And these numbers on the side here, they actually tell you how many times this line of code was executed. So we wrote 2 unit tests, and so we actually executed this code twice. So it still goes to 100%, but we executed this code twice. Quick question? So I think the question is, how do you automate unit tests? Is that right? I see. So you're asking about how do you handle the precision and all of that. It's a good question. We can talk about that afterwards, actually. I want to continue on with this session. Okay. So we just talked about unit test structure. So there's those 3 steps that we're going to continue every time. There's the setup, and there's the actual running of the method, and then there's the verification process. And the next thing that we have to talk about is what to test. And this is a great question. This is just a wonderful question. And I know developers, I've talked to lots and lots of developers, and many times developers are confused, how do I know what to test? And there's a ton of different things that you could test. And, if you go out and you look at unit testing books, there's, all sorts of great different acronyms. Here's 3 things that I think are really important. This isn't everything, but these are some really things that are, these things are really important to test. So one is normal conditions. So, what I showed you here is tests that are testing that my code is working as I expect it to work. And so that's really important, right? Like that's probably the first thing you always want to verify. I've got some code, I want to make sure it works. But then there's also some other things you want to test too, edge cases. And these are like those kind of weird scenarios that like you're just not always expecting to occur. Maybe there's an exception lurking in there somewhere. And you want to make sure that your code handles that gracefully. And the edge cases that we're going to talk about in this session are bad input values. And so like some really common bad input values are 0. So did anyone notice in that fraction question? What if I would divide by 0? It's undefined. So, I've got 100% code coverage in that test, but maybe I didn't handle everything. I didn't handle the edge cases. So 0 is a bad input value. Null is a classic bad input value. That'll cause you an exception every time. The empty string, that's another really good bad input value. So there's lots of those there. You've got to test those. That's important. Also, boundary conditions. And we're going to explore one of those today. So like if you're storing information in an array or a list, typically you've got a finite amount of memory. So, it's possible to actually add one too many to that. And what happens to your code if you add too many values to an array? And there's also kind of the reverse of that. When you try to remove values from an array or other collection that doesn't have any values in it. Those are really common. Those are really common edge cases. And we're going to talk about those today. So to do that, we're going to use a data structure called the stack. And I was searching for, again, good images on the internet. And I'd forgotten about this. But if you guys haven't seen this, cup stacking is awesome. So if you can get on YouTube and check this out, this is really, really cool. These guys stack pyramids of cups in like 5 seconds. It's amazing. You got to check it out. But it's actually not the kind of stack that we're going to talk about today. So we're going to talk about this computer science data structure called a stack. So many of you may not be familiar with this, but it's a pretty common data structure in computer science. And here's kind of an example of it. I've got a stack of things. Like you might think of it as a stack of plates even. But I've got a stack of fruits in this case. And my pear is on top, and then I got a banana, all that good stuff. And if I want to add another value to this stack, there's one method inside of my stack class. There's one way to do that. And it's called push. And so I can actually push that apple onto the top of my stack. And everything else moves down. And if I want to take a value off the stack, there's only one method again there. And I can't take just any value off that stack. I can only take the top value. And the way that I do that is I call pop. So I pop that apple right off the top of my stack. And that's how a stack works. And we're going to use this as our example today. So we're not going to talk about accounts or opportunities or anything that the people that are Force.com developers might not be familiar with. We're going to talk about just strings and the stack object. And again, I'm a visual learner, so I like seeing things in action here. And so I built a little stack class, and that stack class sits behind this page. There's a Visualforce page here. There's a Visualforce controller, and that controller is using my stack class. I'm going to show it to you in a second. But here's that stack class in action. So I can add an orange to my stack class. I can add a grape, and I can add an apple. And if I want to, I can also pop those values right off the top of my stack. So I've written a stack class in Force.com code, and let me show you that class right now. Oops. So it's not super complicated, but let me walk you through it to make sure everyone's on the same page. So internally, we're implementing our stack class using a list of strings. This is kind of a common way to do that. And so we need to find a variable there, and I've called it stack. And we've got a constructor for allocating memory to that list of strings. And then I've got a push method here. So I showed you that before where we push that apple value on top. And pretty much all it's doing, there's some error checking here. But the most important part of this is actually adding that value to the end of the list. So I'm calling a list method here, the list.add, and I'm passing it a value, and it's adding that value to the end of the list. And then to pop things off of the stack, I'm going to remove them from the end of the list. So I call another list method here, list.remove, and I remove the last item from the stack. And that's the most important part of the stack, but there are a couple of other things that I've implemented here. So I've got some helper methods. I've got a method to determine if my stack is full, because there's a limit to the amount of data I can store in my stack. So I want to verify that I want to be able to verify that it is or is not full. And you'll notice I'm actually using that up here. And if it is full, then we're going to throw an exception. And I've got another method, is empty. I want to verify that, if I'm trying to remove a value from the stack, there's something there. Make sure it's not empty. And I've also got some internal exception classes here that handle some exceptional cases. So that's my string class, my string stack class. And let's add a test class. So I'm going to add a new Apex class here. And again, I like to add classes that are named almost identically to the class I'm testing. So I'm going to call this string stack test. And then when I create it, I'm actually going to use a template that's been created for us here, the test class template. So I'm inside of the Force.com IDE, and this is all something that you guys have access to if you download the IDE and write some Apex code with it. So click go here, and everything's going to happen on the server, and we're going to get a local copy. And let me get rid of that comment. It's just going to take up room. So here's our class. And you'll notice that we've got that isTest annotation again. And we talked about that. This is a class full of test methods. And we've got a default test method right here that's written for us, a skeleton. And we could use that if we wanted to, but I've already created some stuff. So I'm going to get rid of that. And I'm going to go down to my snippets. And I'm going to show you the first test I'm going to write here. And we just talked about what to test. And in this case, I'm going to test a normal condition. And this test, verifies that I'm putting things onto the stack and they're going on in the correct order. So, here you're going to see it again. The first thing I do, I set up the conditions for testing. In this case, that means declaring my string stack. And I've also set up some test data. So I've got a grape, an orange, and a mango. And I'm going to push them onto the stack. And that's the second step. So step 2, I'm going to call the push method, and I'm going to do that in the proper order. So I know the order these objects are going onto the stack. And so in the third step here, I can verify that those objects are actually in the stack in the order that we expected. And the way that I do that is I'm going to call stack.pop. And so I'm actually using 2 methods for my class here. And then after that, I'm using, again, assert.equals to verify that the thing on top of the stack, this top string, is actually the thing I'm expecting, the grape. And so I continue on. I continue to do that for all 3 of the values that I put in the stack. I verify that the orange is in the middle of the stack and that the mango was on the bottom. Hopefully it didn't get bruised. Thank you. It's my favorite kind of laugh. And then at the very end here, there's one other thing that we can verify, and that's that the stack actually is empty. And we know that. So we put 3 objects on. We want to make sure that we took all 3 objects off and that there's nothing else left on there. So let's save it. And I'm just going to run the test from here again. Okay, and so let's open up the test runner here. Okay, so we just ran the test. We only ran the string stack test in this case, and we've got 88% code coverage. And that's really good, right? You might say that. 88%, hey, Jesse, that's more than 75%. I can quit now. But this isn't great to me. This tells me that I've got some code that still isn't being covered, and I've only tested one condition. So, there's a couple of ways to figure out what code hasn't been covered. I can look right here. There's that, say, in line 12 and in line 13. So this is another way to check that out, the code coverage. And so I can go back here and check out what line 12 and line 13 are. And these are my exceptional conditions. These are the edge cases that we talked about before. Is there a bad value there? Is there a boundary condition? So I'm not actually checking to see if those boundary conditions are working properly. So I need to write some additional code. I need to write another test method. So we handled the normal case. Let's handle an edge case. And let's attack that bad input value edge case first. Okay, so this is the null value not allowed exception test. So I named it that very deliberately. That's a long name. It took me probably a minute, 2 minutes, maybe hunting and pecking to type that out. But it's really valuable for other developers because it tells them exactly what this is testing. So if it fails for any reason, it's going to show up. It's going to be pretty obvious. Which case did we miss here? Which is the failure? And there's also an interesting pattern in this test. And this pattern could be really useful for you. This might be a tip that you haven't seen before. But when you're testing exceptional conditions, it can be really hard to fire those exceptions, right? Getting everything set up, it's weird. How do I verify that the exception was triggered? So in this case, we do the setup. We create our string stack. And in the second step, we're pushing a value of null. This is our edge case, right? It's a bad input value. So we push null onto the stack. And the interesting thing here is that it's inside of a try block. So right here, we're going to try it. We're going to try to push this null value onto the stack. And if we fail, we're going to catch an exception. And the exception in here is that null value not allowed exception. So, good name for my unit test. But in this case, we're only going to catch this exception. And that's maybe kind of a subtle point. I'm not sure. But if any other exception is thrown here, if it's like a array out of bounds exception or heap exception or something like that, we're actually not going to catch this. So the only way that that this test will pass is if we catch this exact exception, because I've kind of inserted this bomb down here. So if I don't catch this null value not allowed exception, I'm going to fail. I'm going to make this test fail. And the way that I do that is by calling system.assert false. So this is a pretty useful pattern. I know I've talked to lots of developers that have struggled figuring out how to do this. And it's something that you can take away here. Catching that exception, the one specific exception that you're looking for, and if you don't catch that one, then automatically fail. And so this is a good way to write that kind of unit test. Okay, so let's save this one. And what do we have here? We had 88% code coverage. So let's rerun this test and see what happens. Okay, so we're passing, so that's really good news. And now we've only got one line that's not tested, and now we've got 94% code coverage. So that's great. We went up 6%. So we're showing progress here, and we've covered one of those exceptional conditions. So that's really good. And we could stop there, right? We've hit our 94%. But maybe we've got clients and they really want the exact application that you promised them. So we've got to make sure that we're writing all of the functional unit tests that are needed. So 100% code coverage, not that important. Really the idea is, if we're testing everything is working as it should work and we're handling those edge cases, then we can start to feel a lot more confident. So there's one more test that I'd like to write against this string stack, and that's that edge case, that boundary condition edge case. And I can test this by hand too. I could go to that Visualforce page and I could add lots and lots of strings to that stack, and I could see how far I could make it grow. But it's really tedious and time consuming. So this is another benefit of test methods. So I can test something that if I had to test it by hand, it would take me forever. And so I can automate this. And so I've got a test here. It's called Stack Overflow Test. And again, I set up the conditions. And then I've got to call the push method. I've got to trigger the scenario that I want to occur. And the way that I do that is I totally fill up the stack. And that's what this code does here. So while the stack's not full, I'm just going to add lots and lots of bananas to my stack. And after I've done that, then I'm going to actually add one more banana. And hopefully, because this is the way I expect it to work, this is the way I expect that exception to happen, hopefully we're going to throw a stack overflow exception. And if we do, that's great. We're going to return, and this test method is going to pass, and we're going to be really happy. If it doesn't, we're going to blow up by calling system.assert false. So let's hit save, and let's run this test again, and let's see how we're doing. Okay, so it passed. That's good news. And now we've got that 100% code coverage. So, I'm feeling pretty good up here as a speaker. I've shown you 100% code coverage. But I encourage you to take a look at this code because there's actually a few more test methods that I really think should be written here. There's kind of some lurking problems that might crop up. So even though I've got 100% code coverage, I actually know that there's some potential other problems in here. So 100%, I really, if there's one thing you take away, I would encourage you to kind of get out of the mindset of, I got to hit 75%, or I've got to hit, 100%, and really kind of more approach it from the perspective of, I've got these functional requirements, and I have to make sure that my code meets those. So I've got to test normal things, I've got to test edge cases, and really focus on that. And if you do that, I'm absolutely confident, 100% confident, that you'll have no problem exceeding that 75% code coverage requirement. It's just going to happen. Okay, so what to test? Normal conditions, edge cases. There's two things we didn't talk about. We don't have time for this today, but I want to point them out. So regressions. So these are bugs that get introduced into your system. And every time a bug gets introduced into your system, I would strongly encourage you to go out and write a test method that replicates that exact bug. So write that guy. This is what we do internally. This is what our R&D team does internally. So if a customer like you, maybe you've done this already actually, maybe you've gone through this process. If you find a bug in Salesforce, Force.com, if you do that and you log a case that goes to our R&D team, they identify it as a bug, they say, okay, we got this, let's write a test method for this. Let's write a unit test for this. And so that's the first thing they do. And then once they can replicate that bug inside of a controlled test, then they actually go out and fix it. And they know that they're done when that test method passes. So this is a great best practice to implement with your own code. And unfortunately, we don't have time to talk about today. But the other thing that I want to touch on, because it is important, is that there are some Force.com specifics for when you're writing your test methods. And one big one that we're not going to be able to talk about is triggers, actually kicking off a trigger. But the good news is that the page that's associated with this, there's actually a whole wiki article called How to Write Good Unit Tests, and it covers this example in depth, how to kick off a trigger, if you're inserting an account. And so I'd encourage you to look at that. And also some other things that are pretty specific to Force.com, Apex callouts, the way you handle that, testing governor limits, also really important. That information is covered in a separate document, but it's linked from the session resource page. So great information there. I really encourage you to check it out, and you can reach it from our session resource page. So we've had a pretty good day, and I'm really happy that you're all still here. It really makes me feel good. So unit test, a definition, talked about that, figured out what unit tests are, talked about why they're important, talked about how to structure unit tests, we talked about what to test. And another thing that we haven't talked about yet, though, is what's the sniff test? Like, how do you know as a developer if you're writing a good unit test? And I think there's 4 aspects to this. And there's probably more too that we could talk about. But I think there's 4 just super important ones that are critical. And the first one's, your unit tests, they got to be thorough, right? Like, on the spectrum of how much to test, you could test absolutely nothing. And that's like virtual suicide, right? Because you've got no idea if your code works. Or you could try to test everything, which is probably ridiculous because, you have to eat and sleep too. So you got to come in somewhere in the middle, but you should be thorough. You should test all those functional tests that are really important, all the requirements for your code. And the other aspect of being thorough is, again, using system.assert. It's really, really important. If you don't use that, it's kind of tough to have a lot of confidence in your code. So thorough, that's the first sniff test. Repeatable. So how many people, I don't know, this is kind of a trick question, so maybe that gives you the answer. But how many people think that it's possible to write, in your development environment, unit tests that have 100% code coverage, and then move that to production and find out that your test methods have 0% code coverage? How many people think that's possible? All right, you guys are pretty smart. It's absolutely possible. You can totally do that. You can write test methods in your developer environment, 100% code coverage, move it to production, everything just bombs up. Everything fails, 0%. So the reason why that is, or 0% pass rate, sorry, I shouldn't say code coverage, pass rate. And the reason that is because those people have used information that is inside of the developer environment only. So maybe you created an account from inside of the web interface, and then you're actually testing. You're searching for that ID, that account ID, and then you're testing against that. Well, when you move to production, you're going to have totally different IDs. So that test is going to fail. So the best practice here is create your own data. And man, if you see a hard-coded ID, that's a red flag. Like, that test needs to be rewritten. So thorough, repeatable, automatic. So this is pretty important, right? Like, you don't want to have to go through, my little example there with the fraction and enter all of the different numbers. You want to be able to just run those with the click of a button, or you want to be able to schedule them. And that's actually possible too. So there are some other tools that you can use. You can use Ant to schedule your tests. You can make them fully automatic if you want to. But really I think it's important to be able to run them by clicking a button and not having to do everything manually. And then finally, independent. So there's 2 aspects to this too. The first one is, ideally you would only test one part of your code at a time. So you'd write one test method that does exactly one thing. In some cases, you're not going to be able to do that. It's a best practice. In the example that I showed, in order to verify that that stack was growing properly, I had to call 2 methods, right? I had to call push and add values to my stack, and then I had to call pop and remove values from the stack. And so, there wasn't a way around that for me to verify that everything was working correctly. So I had to test 2 aspects. I had to test push and pop at the same time. But, when you can avoid that, I would encourage you to do so. And then kind of a common thing, typically when you're writing unit tests in Java or .NET, is you got to make those tests independent from each other. But again, this is a benefit of Force.com code in that when you finish your unit test, nothing gets committed. So you don't have to worry. There's actually no way for one of your test methods to depend on the state at the end of another test method. So that's really good news. That'll save you some time. So we've had a pretty big day. We've had a pretty big morning. We've had a pretty big conference. And we've talked about lots of great stuff. We've talked about what unit tests are, the benefits, and how to write good unit tests. And so I think there was a question here earlier, am I going to love unit tests at the end of the session? And I don't know how I did, but I hope this was some good information. I hope this will help you write better unit tests in your job. And there are some next steps. You've seen this before. Some great content available out in the dev zone. I'd encourage you. Those cheat sheets are really great. I'm really excited about those. Also, Force.com Free Edition, Developer Edition, great stuff. Hope you have that already. And personally, the most important thing for me is I'd really love to get your feedback. I'd love to talk with you now or a little bit later on today. And also, getting your feedback online too. That's pretty important for me. I'm measure on this, and I'd like to get better. So let me know if there's something that we should have covered in more depth. Is there something I talked about too much? I'd love to get your feedback. But I really appreciate your attention. I really appreciate you being here. I hope you had a great Dreamforce. And if you have any questions, I'm happy to talk to you now on the mic or later on afterwards as well in the dev zone. Thank you. If you can ask your question either at the mic or I can repeat it as well. Yell it loud. There is a button to run all tests, and the way that you do that is by going into Apex classes, and I'll show you that right now. So again, set up Apex classes, and then run all tests. So thank you for that question. It's a good point. And we'll run all the tests here. And we'll go on this side first, and then we'll come to you, sir.
Yes, I'm wondering if there's any best practices around generating large sets of test data, because doing it programmatically can be a drag.
Generating large sets of test data. So you're saying actually writing the Apex code to create those objects can be kind of frustrating.
If you have to do it programmatically, yeah.
Yep, I can understand that question. I can understand how that can be very difficult. That's the best way to do it. I'm glad you mentioned the word best practices, though, because there's also some Apex best practices document. There's an Apex best practices document, and that may have some information on that. I don't know, but you're not able to use the data loader or anything like that, unfortunately. So thank you for your question.
Hi. I have 3 questions. First one is if you have a complicated set of logic classes and you'd like to test them in isolation, is there any way to do what the rest of the industry calls dependency injection or inversion of control, actually separating the logic out so that you can test one class at a time with stubs or mocks or something like that?
Sure. So the person that you should actually talk to about this is the Apex product manager. He's going to know a lot more information about what our roadmap is in the future, which is what you're going to need. His name is Taggart. And if you go out into the dev zone and you ask around and say, hey, I need to talk to Taggart, hopefully someone will be able to point you to him. I know he's around today. So he'll be the best person to ask.
All right. Second question is there a way to unit test controllers or the view code?
Great question. So is there a way to unit test controllers? And there is. And pretty sure it's in the Apex Developers Guide. It may be in Visualforce, but let me show it to you here. I think it's in Visualforce. So I've got these bookmarked, but all this documentation is available on developerforce.com, and custom controllers and controller extensions, and then testing custom controllers and controller extensions. So this should be a pretty good start for what you're looking for there.
Okay, thank you.
Okay. And sorry, is one more question?
I thought there was, but I can't think of it.
Okay, great. Well, we can talk about it later. No problem. And we'll go back to you.
Could you explain the difference between system.assert and system.assert equals?
Oh, excellent question. Great question. So let's bring up the example here. So the basic difference is that it's one value or two values. So let me try to find it real quick here and show you that difference. Here we go. System methods. Okay. So the assert method, it essentially tests a Boolean condition. So it verifies that something is either true, or hopefully true, that's the way it's going to pass, or that it's false. And the assert equals and the assert not equals actually compare two different values and verify that those values are equivalent. So kind of internally, it's doing that comparison and sort of passing the values, the result of that comparison off to assert and determining whether or not that comparison is equal.
And when would you use each one?
When would you use each one? So let's say you've got a method that returns. So the example that I showed you actually before in my test. So here's an example. So I wanted to verify that the mango was actually the string that was at the bottom of the stack. And down here, and so that's comparing two strings, right? I'm comparing whether or not they're equal. And down here, I'm verifying that the stack is actually empty. So this isEmpty value returns a Boolean. Now, there's a way that we could actually use system.assert. And essentially what's happening in that assert equals is this comparison. So you could actually do this, and let me see if I have the syntax correct. I may not. Okay, so it looks like that worked. And let's rerun it, and everything should pass, and it does. So that's kind of the difference there.
Makes sense. Thanks.
Thanks. Good question.
You mentioned that for all the test data is not going to be committed, which is true. But what I noticed is if the object has an auto number, it gets incremented. Is there a way to avoid that?
My understanding of your question is that if you've got a custom object and there's an auto number field on it, if you actually run test methods, you might have a gap between
Yes.
your objects. So if you've got one object that's auto number 000, and then you run two tests and insert two objects, your next one will be 0003, right? It's a good question. I don't know the details about that. I recommend one of two things. Maybe look on the developer boards and see if that's already there. I don't know the answer off the top of my head. Or the other thing that we could do is we could go out and we could try to find Taggart, the product manager, and see if there's a way to override it. I suspect that this has probably been logged before. I don't think that there's a setting for it. So that may be a bug that they're already aware of. So thank you for that question. And so you can come see me, or we can go find Taggart later if you'd like. So,
Hi. How do I test Apex Web Services? Sorry, I didn't see him.
sorry, go ahead. Go ahead.
Okay.
Sorry.
Web services, how do I test them?
How do you test web services? So let me show you the URL for the website that I was talking about before. So here's the website. This is it's associated with this session, and this is going to be a really great resource. So if you want to watch this video again or send it to someone, it'll be available within like the next week or so. In addition, there's also this link I've created here called Additional Resources. This is all available on developerforce.com. It'll be pretty obvious if you go there. And there are some examples here about introduction to Apex code test methods and some other best practices. And it's a little bit more complex than what we talked about today, but it is possible to test web services. The important thing to know is that you're not actually going to make that call out to the web service. But there are resources available for that.
Okay.
So I apologize for skipping you.
No problem. My question is, like, when you try to test Visualforce pages which rely on query strings, how do you set those query strings in your test method?
So you're asking, how do I test the Visualforce page and set the query string? And then test that. Is that right?
Like, when I use test.setCurrentPage,
Yep.
I can give the Visualforce page, but let's say I have a controller which has a default constructor, and in that I'm trying to assign some SObject by using the query string. I'm unable to cover the default constructor from the test method.
Yeah. So if I understand your question, you're saying I've got a Visualforce page. I want to pass in values in the query string, and then I want to test to make sure that those values were set properly. If I'm correct, you're going to need to call getParameters. So actually return the parameters from the page and then set that value. And so I know there's a bunch of documentation on it, and we can try to search for it real quick here. And if I don't find it, you can come find me out there, and we can go through it in more depth as well. But I'm pretty confident that what you're looking for is get parameters, and then setting that value. So I think it's probably right here. Yeah, so here's that example. So Apex pages, that current page, get parameters, and then you're going to put a value. The QP value is going to be YYYY.
Okay.
So,
Thank you.
Yep.
This is maybe more of a VF question, but how are you persisting state of that stat class when you're in that test harness, that visual where you're pushing and popping? Can the controller, does it have like the equivalent of session state, or?
So let me show you what the controller looks like, and it's not too complex. I didn't show this before because I didn't want to add too much complication. I wanted to keep it simple. But here's my controller, and so I'm declaring a string stack variable, and then I'm allocating memory for it, and then that persists between requests to that page. So every time I push it, I'm pushing it right onto that string stack object. So, over to you.
So you have showed us how to kick off the test in the IDE or a browser. Let's say I have too many tests, and I like to be able to kick off them outside of those two. So is there something like an API, command line, or scripting way to kick them off?
Yep, there is. And so what you're going to want to do is you're going to want to use the metadata API. And there's documentation on developerforce.com about that. And essentially, you're going to send a message via the metadata API to run all of the tests. And so it is possible. And so search for like the metadata API on developerforce.com. Or I think the other thing you're probably going to want to search for is the force.com migration tool. And I think that's going to allow you to use Ant to actually kick off those tests.
Oh, so they have API supporting Ant.
Yeah, so there's the metadata API, and then we've added I think it's just a jar to Ant that allows Ant and the scripts that you write for it to communicate with the metadata API. And one of the things that you can do is kick off those tests.
Thank you.
Yep.
How do you test a multi-threaded application in F-test? I mean, can you test parallel threads?
How do I test a multi-threaded application? Yeah. Well, you can't create threads really inside of Apex, right? All you can do is create @future requests, and those get added to the queue. I actually don't have any experience writing test methods against @future, but certainly we could go out if you want to meet right after the session, and we could investigate that a little bit more.
Okay, I see. Thank you.
Okay. Well, if there's no more questions, I really appreciate your time, and thank you very much.